Hello, team. We are on 11D, page 106, and we're going to continue to add and subtract rational expressions. This time, we're going to have unlike denominators. The last two sections, we've done like denominators, and we've done denominators that are opposites, and we've practiced combining those, and now we're going to switch to unlike denominators. So, of course, we need a common denominator, just like when you're adding or subtracting normal fractions. If they don't have a common denominator, you need to go get one. So, the common denominator between 6 and 5 is 30. So, I'm going to I call this my shell. I'm going to write the two fractions with the denominator of 30, and I'm going to ask myself, to get from 6 to 30, I have to multiply times 5, so I have to do the exact same thing to the numerator in order to keep this an equivalent fraction. So I'm multiplying both the numerator and the denominator by a clever 1, 5 over 5. So that would look like that. And to get from 5 to 30, I need to multiply by 6. So the clever 6 would be multiplying the numerator by 6 as well. So now that I've got the same denominator, I'm going to write a single fraction bar. I'm going to distribute. The fraction bar is not quite long enough. And then I'm going to collect like terms. 5a plus 6 more is 11, and a positive 10 minus 6 is a positive 4. Now I want to look and see, are there any factors that I can factor out and cancel in the numerator and the denominator? There are not. 11a plus 4 have nothing in common and doesn't have anything in common with the 30, so this is my answer for problem A. All right, let's move on to example B. Again, we've got three different fractions. You don't see any denominators on the first two terms, but the denominator really is there. It's the ghostly 1. So we need a common denominator, and the common denominator between 1, 1, and 5 is 5. So if I'm going to rewrite all three of these with the denominator of 5, I've got to change the numerators of the first two terms by the same thing that I changed the denominator. So 1 times 5 is 5, so I have to multiply p by 5. 1 times 5 is 5, so 4 times 5 is 20. So now noticing I've got this third term I'm subtracting, so you may want to go ahead and put parentheses, grouping symbol around there to remind you that this negative sign is going to distribute to each piece, each term that's on the inside of the grouping symbol. Single fraction bar, 5p plus 20 minus 1 more p minus 2. And collecting like terms, we get 4p plus 18 all over 5. And again, I'm looking for a common factor to factor out of the numerator. I could take a 2 out and write it like this. And either of these answers is fine, but there is nothing that cancels numerator and denominator. So quite often, you'll see it just left like this. But that's an acceptable answer as well. Let's look at these last two examples in this video. 4 and 12, common denominator, lowest common denominator. And I failed to mention that we are always looking for the lowest common denominator. So that would be 12. This second fraction's okay, but to get from 4 to 12, I need to multiply by 3. So I need to multiply the numerator by 3 as well. Now I'm ready to do a single fraction bar. I'm ready to distribute and collect like terms. 3x plus 1 more is 4x. Negative 3 plus 5 is positive 2 over 12. And I see a whole bunch of even numbers here, so I know I'm going to have some common factors. The 2 will factor out of the first two terms, so I get 2x plus 1. In the denominator, I have a 12. 2 goes into 12 6 times. So my final simplified answer is 2x plus 1 over 6. One more example on this video. 6 and 8, I'm looking for a common denominator. Now, obviously, you could multiply 6 times 8 and get 48. And that would be fine, and you'd end up with a whole lot of canceling. But as you move forward in algebra, we are always looking for the lowest common denominator. not just any old common denominator. So to remind you how you find the lowest common denominator, you start with the prime factorization. So for 6, it's 2 times 3. For 8, it's 2 cubed. The LCM, lowest common denominator, lowest common multiple, which is in this case the lowest common denominator, you take every base you see, but you only write it one time. So I see a 2 and I see a 3, and you put the highest exponent on it. So that's 8 times 3, which is 24. So that is your lowest common denominator. In this case, you probably saw that already, but this little trick of using your prime factorization will always work for numbers where it's not so obvious. To get from 6 to 24, I multiply times 4, so I have to multiply the numerator times 4 as well. 8 times 3 is 24, so 3 times u plus 1. I'm noticing this negative sign right here, so this is going to remind me that I've got some distribution when I get to that piece. Single fraction bar, 4 times u is 4u, 4 times 5 is 20, and then minus, and then this is 3u plus 3. And I'm putting that in a grouping symbol to remind you that your next step will be distributing the negative 1. So 4u plus 20 minus 3u minus 3 all over 24. Cleaning it up, I get 1u, or just u, plus 17 over 24. And there are no common factors. There's nothing else that'll cancel out. So u plus 17 over 24 is the final answer. All right, I'll continue in the next video on the next page. Bye.